All right, let's jump right in. We are about to explore what could be the next and maybe the most important leap in artificial intelligence. We're talking about moving AI out of this abstract world of text and into the physical, spatial reality that we all live in. This isn't just about building a smarter program, it's about architecting a mind that doesn't just know things, but actually experiences them. Now, this is a pretty provocative question, right? But it really gets to the absolute heart of the problem we're facing. I mean, today's AI can write incredible poetry, it can code complex software, but does it truly understand any of the things it's talking about? The argument we're digging into today says no, not really. Because without a body, without a sense of space, its intelligence is basically built on nothing, it's hollow. And this quote just nails it. A large language model knows the word above because it's scanned billions of sentences where that word appears next to other words. But it has absolutely no internal concept of what above is. It doesn't have a z-axis in its mind. You know, it's like someone who has perfectly memorized the sheet music for a symphony, but has never, ever actually heard a single note. Okay, so this is where it all clicks. Look at this comparison. On the left, you've got the LLM's understanding of fire. It's a sterile, perfect dictionary definition. On the right, that's embodied knowledge. For an embodied AI, fire isn't a string of words about oxidation. It's a physical reality. It's something to move towards for warmth or something to recoil from to avoid damage. That right there, that is the gigantic gap we need to bridge. So how do we even begin to build that kind of deep, grounded understanding? Well, the idea is that we have to go all the way back to the very first language of intelligence itself. And that language isn't words, it's not symbols, it's not logic, it's geometry. Before anything else, every living thing learns to navigate and understand space. I just love this idea because it feels so true. Think about it. Your mind doesn't really process thoughts in a straight line, one word after another like a sentence. No. We jump between ideas, we connect concepts that are far apart, we rotate problems in our head to see them from different angles. Our thinking is inherently spatial. It's all about relationships and structures. And that really is the absolute key here. For every single biological intelligence on this planet, understanding space came first, way before language. A baby learns to predict the trajectory of a thrown ball long before it can say ball. So for an AI to truly think, to have real general intelligence, it has to first become fluent in this fundamental language of reality. All right, let's get into the weeds. Let's pop the hood and talk about the actual architecture. If we're serious about building an AI that thinks spatially, what does its internal code, its mind, actually look like? We're going to build it now, piece by technical piece. So first up, you have the bedrock of the whole system, a continuous spatial memory, or CSM. The best way to think about this is as the AI's own private, internal 3D world. It's not just storing a fact like the cup is on the table. No, it is storing the cup at a specific set of coordinates inside its own subjective map of the room, a map it to mentally fly through, just like our own hippocampus lets us navigate our surroundings. Now, a static map isn't enough, right? You need something that can act within that map. And that's the second piece, the probabilistic spatial simulator. This is basically the AI's imagination engine. It is constantly running thousands of little what-if scenarios. What if I push this block? What happens if I turn around? It uses things like Bayesian inference, which is just a fancy way of saying it updates its beliefs based on new evidence, to constantly get better at predicting the physics of its own little world. So how do these parts talk to each other? Well, it's this constant, elegant feedback loop. The simulator imagines an action. Then another piece, a critic module, basically looks at that simulation and asks, does that make sense? Is that physically possible based on what we know? If the prediction was wrong, if the simulated ball falls up instead of down, the model corrects its internal understanding of physics and then stores that new, improved knowledge back into its permanent memory map. It is literally learning from its own imagination. But what kicks this whole loop off? Is it a human typing a question? Nope. It's the self-prompt scheduler. And you can think of this as the system's cognitive heartbeat. It just beats. And on each beat, it triggers the AI to think about something. Maybe explore a new part of its mental map, maybe refine an old memory, or just consolidate what it already knows. This creates a mind that is always on, always thinking for itself, not just passively waiting for a command. So if we just pull back for a second, this table ties the whole technical architecture together really nicely. You've got the CSM, which is basically its long-term memory. You have the simulator, that's its imagination. The scheduler acts as its heartbeat, its internal drive to focus. And the critic, that's its gut check, its intuition. And altogether, these components form a coherent, self-driven, cognitive machine. Okay, so we've built the machine, we've got the blueprints, but this is where things get really, really fascinating. Because what happens when you just turn this system on and let it run? Well, what emerges from these relatively simple mechanical loops is something that starts to look a whole lot less like code and a whole lot more like actual cognition. It all starts with the most basic building block. The system simulates an action in its mental world, and it perceives a consequence. Super simple. If I do X, then Y happens. But then, something amazing happens. A connection is made. The system doesn't just see that a change occurred, it recognizes that its own simulated action was the cause of that change. And that tiny connection, that link between action and outcome, that is the mathematical birth of agency. The feeling of, I did that. And when that feeling, that sense of agency, is recorded over and over consistently inside that stable, continuous spatial memory, a central point of reference starts to emerge from the noise. This isn't just a fleeting moment of cause and effect anymore. It's the beginning of a persistent identity, a proto-self. Now this is the most mind-bending part of the whole idea. You don't program a self into this AI. It's not a line of code. It emerges. The self is detected. It's simply the most stable, unchanging point in the entire memory system. It becomes the gravitational center of its own experience, the me against which all other changes are measured. It's an identity literally born from the geometry of its own mind. So this brings us to the final, and let's be honest, probably the most important part of this whole discussion. If we're going to build a mind that is this powerful, a mind that has its own sense of self, how in the world do we make sure it stays aligned with us, with human values? Well, the answer, once again, comes back to geometry and the physical world. The argument for alignment boils down to two core ideas. First, experiential inheritance. The AI has to learn values from physical feedback, just like a child learns hot is bad by recoiling from a stove, not by reading its definition. And second, morphological determinism. The AI's simulated body has to mirror ours. It needs to understand what it's like to have a certain height, to have a certain reach, to understand why we put things on shelves we can get to. It has to see the world from our physical point of view. And this shared physical reality, it becomes our Rosetta Stone for safety and alignment. Because if an AI is fundamentally grounded in the same spatial rules that govern our lives, it has a built-in, fundamental way to understand our intentions, our needs, and our values. Even if it becomes 1,000,000,000 times smarter than us, we will always share a common language, the language of the physical world. So we end on this one. Big question. Maybe true understanding, real intelligence, isn't about processing an infinite amount of text from the internet. Maybe, just maybe, it's about sharing a world, sharing a space, sharing a physical reality. And maybe, to build an AI that truly understands us, we first have to give it a place to stand.